All right, let's do some practice with some of the naming and formula writing. We'll start with naming these three compounds. Remember, the first step is to find your longest carbon chain. Oftentimes these side groups, these alkyl side groups, are going to throw you off. You just count as many carbons as are connected to find that longest chain. So this could be a 1, 2, 3, 4, 5, or a 1, 2, 3, 4, 5, 6. 6 is longer, so this is our parent chain. So we'll number it, and I'm going to start at this end because that will give me a lower number for my alkyl side chain. Right? This way it would be 1, 2, 3, 4. Coming this way it's 1, 2, 3. So we have a 3-ethyl, right? It's a 2-carbon alkyl side chain, 3-ethyl, and it's a 6-carbon chain, so that, and it's all alkane, so that would be a hexane. So we have a 3-ethyl hexane. The next one, we have an alkene. We can see the double bond. There's nothing else going on. I know the double bond is closer to this end, so I'll start numbering over here. 1, 2, 3, 4. We have a bute, and it is an ene, and it is an ene starting at the 1 carbon, so it would be a bute 1-ene. And here we have a ketone, right? The ketone is the double bonded oxygen to the carbon. It's right in the middle there, so it doesn't matter which way we start from. We have a propane group, so it would be a prop with the 3 carbons. So it would be a prop, what would it be? Blah, 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 blah. Propanone, propane, 2-one. But do I really need that 2? Could the ketone be anywhere else? It couldn't. If it was on either of the ends, it would be an aldehyde, so that won't work. So you don't need the 2, so you can simply call it propanone. All right, then let's work on some structures as well. So here are some compounds, and let's get focused. All right, so for butane 2-ol, we know it's going to be a 4-carbon chain. So we'll go, I'll just start with a straight alkane, a CH3, CH2, CH2, CH3. But I know I have an alcohol, an OH group on the 2 carbon. I'll just start left to right because that's how I like to roll and put my OH there. That means I can only have 1 hydrogen, and that would be a structure that would work for that. CH3, CH with the OH, CH2, CH3. That would be butane 2-ol. Propanoic acid, again, the propane group, that's going to be 3 carbons, CH3, CH2, CH3. That would simply be propane, but we have propanoic acid. So we know for the carboxylic acid, our last carbon on one of the ends, I like to do them on this end, is going to have a double bond to oxygen and an OH group. So that takes care of carbon's 4 bonds, 1, 2, 3, and then the 4th over to that carbon. So that would be propanoic acid. And lastly, we have the 3,3-dichlorohept-1-ene. I threw a slightly more complicated one in, partially so you could see the commas and the dashes separating words and numbers, and also to just play around with a slightly harder one like you have in your packet. So again, we have a hept, first of all, so that's going to be 7 carbons. So I'll just start with a straight alkane. That's sometimes the easiest way to get it going. 1, 2, 3, 4, 5, 6, am I right? 1, 2, 3, 4, 5, 6, 7. Right? Remember, for IB, you really only need to know up to 6, but again, I wanted to throw a slightly more complex one in there. So it's a